Good evening, Professor and my fellow classmates. Firstly, I would like to thank our professor for giving us this real-life case scenario to understand aggregate planning. We are Group 1 and I'm Sami Ahmed. My group members are Wen Han Zong, Yang Lu, Muhammad Amirul Hassan, and we will be presenting according to our name structure. So let's get to the introduction. What is aggregate production planning? Demand for many industrial products, including food industry products such as corn, presents highly seasonal patterns, which makes the production and materials management a complex task for any company. So, the aggregate production planning (APP) is concerned with determining the optimum production and workforce levels for each period over planning horizon for the companies. It aims to set overall production levels for each product family to meet fluctuating demand in the near future. Case analysis purpose. Why are we analyzing this case? Because we want to help KPH's production planning through minimizing cost and recommend them alternatives to production and plant planning. We want to help them achieve managerial improvements and mastering production schedule. We are doing this by presenting a spreadsheet model that provides effective support for the aggregate production planning. We are also doing model implementation and product insights using linear programming in Excel. I'll give you a brief case background. KPH assembled planters in Devonport and harvesters in Ames. Demand for planters peaked in March, whereas demand for harvesters peaked in September. They were both seasonal demands. But each plant aimed for a production plan that allowed them to meet annual demand at the lowest possible cost. KPH could also choose to delay a customer order by stocking out in a given month and filling the stock out from the next month's production. They also had to pay incentive for that. The company had a policy of ensuring that there were no stockouts in December, so the new year started out with any unfilled orders. All the costs that were mentioned in the case will be discussed in details by my group member in further slides. Now I would like to pass it to my next group member for presenting his part. Thank you so much.
As stated by my teammates before, KPH is looking for a plan that can lower the costs. So let's take a look at all the factors that can influence their decision. The first is the costs. These are all the costs needed to be considered for setting up plants and manufacturing. From this chart, we can see that holding cost is $300, which is much lower than the cost of stockout. And at the same time, the costs for laying off and rehiring workers were high. Another aspect is demand. For the planters, we can see that there is a peak around March, and in other time of the year, the demand for planters are relatively low and stable. On the other side, the demand of harvesters reaches the highest point around September. Also, the same as planters, demand in other period of the time is relatively low. So, in addition, there were also inventories and workers left from the last year from both of the plants. So for KPH, there are two options for them. The first is to build two factories separately for manufacturing planters and harvesters. And the second option is to only use one factory to produce both products. So for the management of KPH, their problem is how to trade off among the demand, inventory, and workforce, and which options to choose. For next step, we will dig deeper to these factors that can influence KPH's decision, and let's welcome Ellie to discuss the next part.
My name is Yang Lu. The part I'm going to introduce is problem-solving methodology. As we mentioned before, there are two alternatives to help the company solve the current problem. The first option is to continue to use two separate plants to produce planters and harvester respectively. The second option is to use a single plant to produce both planters and harvesters. We use linear programming to resolve this planning problem. For the first option, we calculate the minimum production costs of two plants in a year and then add them together to get the final total cost. For the second option, we add the workforce and inventory of two machines at the beginning of the year represents the new workforce and inventory after the merged plant. The sum of the monthly demand represents the new demand for each month. At last, we use solver to get the minimum total cost, that means the constraints. Because the basic method to calculate production cost of two options is very similar, I will introduce this method through the operation process of the second option. The first step is determining the decision variables for production costs. There are 7 decision variables, include number of employees held at the beginning of every month, number of employees laid off at the beginning of every month, workforce size for every month, number of overtime hours worked in every month, inventory at the end of every month, number of units stocked out at the end of every month, and production in every month. In solver, we choose the part covered by yellow as the changing variables. The second step is determining the composition of the production cost. The total cost include hiring cost, layoff cost, regular time labor cost, overtime labor cost, inventory holding cost, marginal cost of stock out, and material cost. Each cost can be calculated by the decision variables I mentioned before. Then, add all of the costs together as the total cost and minimize it to get the optimum result. The last step is determining the constraints. The first constraint is that hired and laid-off workers are integers. The second constraint is that all decision variables are non-negative. And the third and fourth constraints are planned ended December of the coming year with the same labor and inventory as the previous December. The next constraint is ensuring that there's no stocks out in December, so the new year started out without any unfilled orders. The last 3 constraints are inventory balance constraints, overtime limit constraints, capacity constraints, and workforce hiring and layoff constraints. Inventory balance constraints means that inventory of last month plus production of this month plus stock out of this month are equal to demand of this month plus stock out of last month plus inventory of this month. Overtime limit constraints means that the monthly overtime hours cannot exceed the minimum overtime hours. Capacity constraints means that the monthly production cannot exceed the total output of normal work and overtime work. Workforce hiring and layoff constraints means that the workforce per month is equal to workforce of previous month plus the workers held this month minus the number of workers laid off this month. Then we go to the result. The optimum total cost of producing planters in option 1 is 113,936,320. As seen in the chart, due to the seasonal demand, the factory's production from January to May is very high, but the production has dropped greatly from June. Similarly, the production and the inventory of harvester also fluctuate greatly within a year. From May to October is very high, and the remaining months are low. The optimum total cost of producing harvester in option 1 is 112,729,860. The total cost of option 1 is to add them together. For the second option, the production of machine is relatively stable every month. The optimum total cost of option 2 is 221,861,700. Comparing the production costs of those two alternatives in a year, it is found that the cost of company to build a single factory is less than the cost of company to build two factories to produce planters and harvesters separately. Therefore, along those two options, the second option is more worthy of recommendation. After that, we compared the 6 costs of two options. Except for the regular time labor costs, the other 5 costs in second option are all lower than the first option. Reducing the cost of hiring and layoff means that the company's workforce is more stable. In a long-term stable workforce environment, labor costs per unit may decrease due to learning new skills and improving work experience. In addition, also the cost in regular time of the option 1 is lower than option 2. The cost in overtime is higher. When those two costs are added up, the total cost of manufacturing in two factories is higher than using a single factory. Therefore, establishing a single factory is conducive to the long-term development of the company. Then our team member will explain the recommendation and the result parts.
Hello everyone, this is Mohammed Hassan and I'm going to talk about recommendation and conclusion. For recommending which one should KPS manager go, we'll have to figure it out the both alternatives. Option 1 is to replace each factory with a new one, and the option 2 is to expand the Devonport plant for assembling planters and harvesters altogether. My colleagues already described cost details of the both options. In option 1, regular production cost is less than the option 2. But if we see the additional cost details such as layoff, rehire, overtime, inventory carrying cost, etc., then we can find out that overall the combined plan is much more cost effective than option 1. So we are recommending option 2 because KPS can reduce the cost and increase the profit margin by that. On top of that, KPS don't need to take the hassle of laying off employees and rehire them. And their workforce will also remain stable. Stock out would not take place as well. So KPS can also reduce the uncertain cost. Every business has to deal with some kind of situation before taking a strategic decisions. A perfect move can increase the profitability. An organization can finalize its business plan on the recommendation of the demand forecast. Once business plans are ready, the organization can do backward working from the final sales unit to the raw materials required. Thus, annual and quarterly plans are broken down into labor, raw material, working capital, etc. This process of working out production requirements for a medium range, all the processes can be done by aggregate production planning. A significant advantage of using aggregate production planning is that it maximizes the utilization of production equipment. This creates a much more streamlined process where businesses can accurately determine the time it will take to fulfill orders and then plan their production operations accordingly. Additionally, aggregate production planning involves developing a general plan for employment, output, and inventory levels. The goal is to develop a plan that makes efficient use of resources of an organization. That's it, everyone. If you have any question, please feel free to ask us. Thank you.